Hello everyone. I welcome you all once again to my channel. So before we move towards today's discussion and today's lesson, please like, share and subscribe for more discussions and more lessons and other contents. So let's begin our learning journey together. Today the topic that we are going to discuss is exercise 1.1 second, third and fourth problems of chapter 1. In the previous video I discussed exercise 1.1 first problem in which there were three questions. So today we will discuss problems second, third, fourth of exercise 1.1. So let's move to the second question. So read out what the question is given here. The second question is use division algorithm to show that any positive odd integer is of the form 6q plus 1, 6q plus 3 or 6q plus 1 where q is some integer. Okay. So let's move to the solution. You all are familiar with division algorithm, right? So if you are new to what division algorithm is, you can check out my previous videos in which I completely explain what division algorithm is. So first here we need to show that any positive odd integer is of the form 6q plus 1, 6q plus 3, 6q plus 5. So the positive integer, let us take it as a. Let a be any positive integer. Okay. Next, apply division algorithm. So from division algorithm, I think you remember that we have equation that from division algorithm we have a equals to bq plus r with condition 0 is less than or equals to r and r is less than b. Okay. So in this question, what is the value of b? 6. Okay. So 0 is less than or equals to r. R is less than 6. Now here look, r is less than 6. So what are the possible r values will get? Possible r values are numbers less than 6. So that are 0, 1, 2, 3, 4 and 5. So these are the possible r values that we need to substitute. So from the division algorithm that we have is a equals to bq plus r. Now a equals to, what is the value of b? 6. 6 into q plus r. Let us assume this as equation 1. So now all these r values, what are the r values? 0, 1, 2, 3, 4, 5, right? Substitute all these values in equation 1 to get the forms which are in the question. So let us substitute each of these values and see what we'll get. Now we have a equals to 6q plus r from equation 1. A equals to, first, when r equals to 0. So substitute r equals to 0. So what you'll get? A equals to 6q. Next, take r equals to 1. So a equals to 6q plus r. Substitute r equals to 1 in this equation. So it will be 6q plus, what is the value of r? That is 1. So When r equals to 0, we got a equals to 6q, and when r equals to 1, we got a equals to 6q plus 1. Next, what is the next value? 2. R equals to 2. A equals to 6q plus 2. When r equals to 2, you will get a equals to 6q plus 2. Similarly, look for values 3, 4 and 5. When r equals to 3, a equals to 6q plus 3. When r equals to 4, a equals to 6q plus 4. What is the last value we need to look? 5. When r equals to 5, a equals to 6q plus 5. So, the possible r values that are 0, 1, 2, 3, 4, when substituted in the equation, that is in the division algorithm, a equals to bq plus r, we get the following equations. When r equals to 0, a equals to 6q. When r equals to 1, a equals to 6q plus 1. Similarly, for 2, 3, 4, 5, you will get these equations. Now, we need to show that any positive odd integer is of the form 6q plus 1, 6q plus 3 or 6q plus 5. So, here the even integers are not required. So, only the odd integers are required. So, if you remember, even integers are the numbers where nothing is left in the remainder. Or you can remember by even numbers. What are the even numbers? 2, 4, 6, 8, 0. All these are even numbers. So, in this equation, 6q, r is 0. So, this is not positive odd integer. Next equation we have is 6q plus 1. So, this will be the positive odd integer. Next, a equals to 6q plus 2. This is even. So, this is not odd positive integer. 6q plus 3. 3 is odd number. So, this will be odd positive integer. Next, 4. 4 is an even number. So, this is even, which is not required. Next, 5. This is odd positive integer, which we are expected to get. So, from the question, we got 6q plus 1, 6q plus 3 and 6q plus 5. So, you can write the last statement that for every positive odd integer that we took, a, if you remember in the first step, we took let a be any positive integer. So, for every positive odd integer that we took, a is of the form 6q plus 1, 6q plus 3 and 6q plus 5. So, this is the second question. So, that was the second question solution. So, let a be any positive integer, and from division algorithm, take this equation a equals to bq plus r and substitute r values. You will get equations, and you can find out that for any positive odd integer, it is of the form 6q plus 1, 6q plus 3 or 6q plus 5. Next, we'll look third solution. It is similar to the second one, but concept is little different from the second question. So let's see what is in the third question. The third question is use division algorithm to show that square of any positive integer is of the form 3p plus 1. Here the positive integer, they are mentioning it as square of any positive integer. So let's move to the solution. First, what we need to consider? Let First we need to consider some positive integer. So let a be any positive integer. Okay. Now from division algorithm, what we have? A equals to bq plus r, where 0 is less than or equals to r is less than b. So here, what is the value of b? 3 from the question. So a equals to 3q plus r. Now look in the question that they mentioned that square of any positive integer. So we need to square the positive integer. What is the positive integer here? A. So square a. Then you'll get a square equals to 3q plus r whole square from this equation. Okay. Now look here. In this equation, it is of the form a plus b whole square. Now expand this. What is the formula of a plus b whole square? A square plus 2ab plus b square. Right? Now what will be the above equation when we expand this formula? A square equals to 3q square plus 6qr plus r square. Now a square equals to 3 square. How much is 3 square? 9. 9q square plus 6qr plus r square. Now we can simplify this equation like this. See, here we have 9, here we have 6. If we take it out common from this, this both will go in 3 table. So if we take 3 as common, so 3 3s are 9. 9. So 3q square plus, here how much is 6? 3 2s are 6. Qr is as it is plus this r square. Okay. Now put p equals to 3q square plus 2qr. In place of this equation, place it as p. So what equation you'll get? A square equals to 3p plus r square. Okay. You need to substitute this p equals to 3q square plus 2qr. So what you'll get? Then we got the equation that is a square equals to 3p plus r square. Take this as equation 1. Now we need to check the possible r values. So possible r values. Can you quickly say me what are the possible r values in this question? So 0 is less than or equals to r. R is less than b. What is b here? 3. So what are the possible r values? R equals to 0, 1 and 2. Okay. Now all these r values we need to substitute in equation 1. Check all these possible r values in equation 1. So what is the equation we have? A square equals to 3p plus r square. When r equals to 0, we have equation a square equals to 3p plus r square. if you substitute r equals to 0 in this, what you'll get? A square equals to 3p plus 0 square, which is a square equals to 3p. Okay, this is the first one when we substitute r equals to 0. Similarly, when r equals to 1, a square equals to 3p plus 1 square. So what will be the final answer of this equation? That is 3p plus 1. So when r equals to 1, we get a square equals to 3p plus 1. Similarly, when we take r equals to 2, a square equals to 3p plus 2 square. So it will be 3p plus 4. So in the question, we need to show that the positive integer is of the form 3p or 3p plus 1. So when r equals to 0, we got 3p, which is mentioned in the question. We got this 3p. When r equals to 1, we got 3p plus 1, which is also in question. So we obtained this also. Now look at this. When r equals to 2, so how you can write this 3p plus 4? 3p plus 4, this can be written as, if you take out 3 from this, p plus 1. You can simplify this equation like this. So 3 into p is 3p plus 4. Okay. So it is of the form 3p plus 1. Okay. So what you'll write the final statement? So every a square positive integer is of form 3p or 3p plus 1. Nothing in this question. They just mention that the positive integer that we are taking in the previous problems as a single one, in this we need to square that positive integer. So when we square that positive integer, you will get something equation like this. You need to expand the equation and then look out at the possible r values and substitute possible r values in the equation, and you can see that you will get that required forms which are mentioned in the question. Okay, so let's move to next question. Look at fourth question. Here, read out the question. What the question is here? Use division algorithm to show that cube of any positive integer is of the form 9m, 9m plus 1, 9m plus 8. So in the third question, we did square of the positive integer. In fourth question, we are doing that positive integers cube. So very similar to the third question, the fourth one is just in place of a square, you need to do a cube. So the solution is here. First, let a be any positive integer. First step we define. Next, what we will define? By using division algorithm. What equation we have? Division algorithm is a equals to bq plus r with condition 0 is less than or equals to r, r is less than b. Now, cube of a, that is cube of positive integer. So we consider the positive integer as a. So we need to do cube of this a. So when we do cube of this integer, what equation you'll get? A cube equals to bq plus r cube. Now a cube equals to, what is the value of b? Quickly answer me. Right, it is 9. So b value is 9. 9 cube plus r cube. Now you quickly say me in which equation is this in the form? So it is in the form a plus b whole cube. So expand it, you'll get a cube equals to 9m whole cube plus 3, here it is cube. So next 9m is cube r plus 3 9m r square plus r cube. So when you simplify this, you'll get a cube equals to 27. This simplify it, you'll get how much you'll get? Right, 729 q cube plus here 3 or 9 square is 81. 81 q square r plus 9q r square plus r cube. So the final step 729 q cube plus 81 into 3 243 q square r plus 9 3s are 27 q r square plus r cube. Now we will simplify this equation. It is a little complex. So how you will simplify this? A cube equals to look at these numbers 72, 24, 27. All this goes in 9 table. So we'll take it out 9 as common. So it will be 81 q cube plus 27 q square r plus 3q r square plus r cube. Now the equation we got is a cube equals to 981 q cube plus 27 q square r plus 3q r square plus r cube. Now substitute m in this place. So put m equals to 81 q cube plus 27 q square r plus 3q r square in the above equation. So what you'll get? A cube equals to, what you'll get? 9m plus r cube, right? So consider this as equation 1. Now we need to find the possible r values. So quickly say me, what are the possible r values in this question? Okay. So as the condition is 0 is less than or equals to r, r is less than b. So what is the b value? It is 9. So we'll get all the values less than 9. So what are the possible R values? 0, 1, 2, 3, 4, 5, 6, 7, 8. So these all are possible R values. Now we find out the form which is mentioned in the question by substituting this possible R values in the equation 1. So from equation 1, when R equals to 1, 9m plus 0 whole cube equals to what you'll get? 9m. So a cube equals to 9m. When R equals to 1, a cube equals to 9m plus 1 cube. What you'll get? 9m plus 1. When R equals to 2, you'll get a cube equals to 9m plus 2 cube. That is 9m plus, how much is 2 cube? 2 into 2 into 2. 2 2s are 4, 4 2s are 8. 9m plus 8. So similarly, you can look for R equals to 3, 4, 5, 6, 7, 8 in a similar way. In the question, we need to find just the form 9m, 9m plus 1, 9m plus 8. That we got by substituting R equals to 0, R equals to 1 and R equals to 2. So when R equals to 0, we got a cube equals to 9m. When R equals to 1, a cube equals to 9m plus 1. When R equals to 2, it is 9m plus 8. So what is the final statement you can write? Cube of any positive integer is of form 9m, 9m plus 1 and 9m plus 8. Okay. So that's all for today's class. If you have any doubts, you can comment down and try solving more problems. Bye bye.